And today I'm going to be going over balancing equations. And so for the first steps of balancing equations, it's going to be very similar to what we did in the last section where we were just counting the atoms on both sides. That's actually the first step that we go through. Okay, so again, I like to just separate my two sides from the reactants and the products and then list the elements that I have on each side. So I have Hg on this side, so I'm going to have Hg on this one, and then oxygen and oxygen. All right, so for my reactant side, I have no subscript, and so I only have one. Same with oxygen, there's no subscript, so it's understood to be 1. Okay, and then on my product side, the Hg only does not have a subscript, so it will be 1. And then my oxygen does have a subscript of 2, so there are 2 oxygen. Okay, so in order to have balance, because you can see that we are not balanced because here I have 1 oxygen, and then on this side I have 2. Okay, and according to our law of conservation of matter, we have to have the same amount of each atom on both sides of reactants and products. Okay, so the only thing I can change, I can't just come in here and add a subscript to my oxygen because that'll make it a completely different compound. Okay, but what I can do is I can have more of this whole compound on the reactant side in order to help balance out the product side. Okay, so that number is known as the coefficient, and I talked about coefficients in the previous section whenever we were actually counting the different sides of the atom. So for this one, I need my oxygen to be 2, and so since my subscript is 1, I'm going to change my coefficient to a 2. All right, and so that's going to change the amount of each atom that I have on that side. So my Hg is going to go from 1 to now I have 2. Okay, and the oxygen, 2 times my subscript, which is understood as 1, will give me 2. Okay, so now my oxygens are matching, but my Hgs are not. Okay, so I have 2 Hgs on this side, but only 1 on this side, and so I can add in a coefficient here so that this Hg becomes a 2. So now this is balanced as well. So my equation is now balanced. For the next one, again, I like to start out by separating my reactants and products, writing out all the different elements that I have. So I have carbon, hydrogen, and oxygen. So I'm going to have carbon, hydrogen, and oxygen on this side as well. Okay. So counting the amount of atoms I have, carbon, I have 1 on this side, I have 4 hydrogen, and I have 2 oxygen. For this side, I have 1 carbon, 2 hydrogens, and then I have 2 oxygens here and 1 oxygen here, so in total, 3 oxygens. Okay, so my carbons are balanced right away. My hydrogens and oxygens are not balanced. So I'm going to start with my hydrogens because that one's going to be kind of an easier one to tackle. So I have 4 hydrogens on the reactant side and only 2 on the product side. So I can times my water molecule here by 2, the coefficient of 2, so that it will change from 2 to 4. Okay, but then my oxygen, I now have 2 oxygen here, and then 2 times 1 will give me 2 oxygen here. So I have a total of 4 oxygen now on the reactant side. Okay, so my carbons are matching, my hydrogens are matching, my oxygens are not matching yet. Okay, so I have 4 on the product side, I need 4 on the reactant side, it only has 2. So I can multiply it by the coefficient of 2 in order to get my oxygens to 4 on this side so that they are matching as well. Okay, so now I have 1 carbon on both sides, 4 hydrogens on both sides, and 4 oxygens on both sides. For this next one, again, separating my reactants and products, listing out the elements that I have. I have Al, aluminum, and oxygen. Okay, I have 1 aluminum on this side and 2 oxygen on the reactants. And then for the products, I have 2 aluminum and 3 oxygen. Okay, so neither of them are equal, so it's unbalanced. And so if I wanted to increase my aluminum, I would put a 2 here, but I'm actually going to take care of my oxygens first because they're going to be a bit more tricky to deal with. Okay, so for this, I can multiply. I basically find their lowest common multiple. So for 3 oxygen and for 2 oxygen on the reactant side, their least common multiple would be 6. Okay, so in order to get 6 on the product side, I'd have to multiply or use the coefficient 2. Okay, so that I'll change this to now 4, and then 2 times my oxygen would give me 6. Right, and then so on this side, if I want to get 6 oxygen, I need to use the coefficient of 3 so that it gives me 6 oxygen. So now my oxygens match, but unfortunately my aluminums do not. Okay, the reason we waited for aluminum, or we did aluminum second, is because aluminum's all by itself, so it's very easy to multiply out. There's no subscript or anything, so it's easy to manipulate that number. So since we need 4, we will just use a coefficient of 4 so that we now have matching sides and my equation is balanced. All right, this is the last one that we're doing. Separate out my sides and list my elements. So I have potassium, magnesium, and oxygen. Okay, this one is a bit more tricky because if you notice on the product side, I have oxygen in 3 different places, which can make it a bit more difficult to help balance it out. So I'm going to hopefully show you a few tricks in order to help you with this. But first, before we get on to balancing, we need to just count the atoms on both sides. So I have 1 potassium, 1 magnesium, and 4 oxygen. On the product side, I have 2 potassium, 1 magnesium, and then I have 1 oxygen here, 1 oxygen here, and 2 here, so a total of 4. Okay, so even though oxygen's in 3 different places, what's beautiful is that it's already matching, okay? But our problem is potassium. So when we go to manipulate potassium, okay, we have 2 here. We need 2 here, so I'm going to use the coefficient of 2, okay? Now I need to go and recount my reactant side. So 2 times my 1 potassium will give me 2 potassium now, so they match. My 2 times my 1 magnesium will give me 2, and then my 2 times my 4 oxygen will give me 8, okay? So yes, we did balance out the potassiums, but now the magnesium and the oxygens are kind of all messed up. So let's take care of magnesium next. So for magnesium, we have 2 on the reactant side. We need to get 2 on the product side, so I'm going to use the coefficient of 2 here. Okay, recount my side. I still only have 2 potassium. For magnesium, I now have 2. Okay, and then for oxygen, I have 1 here, 2 here, because 2 times 1 is 2, and 2 here. So I have a total of 5 now. Okay, so my potassiums are matching, my magnesiums are matching, my oxygens are not. Okay, So I want to manipulate this oxygen here on the end because if I were to add a coefficient here, it's going to mess up my potassiums again. So really the only thing I want to add a coefficient to is this one. Okay, so if I look at the rest of the problem, I have 1 oxygen here and I have 2 oxygens here. So in total, on this part, I have 3 oxygens. Okay, and then I need 8 in total. So I have 3 here, so somehow I have to turn this one into 5. Okay, so how do we guess, because it has a subscript of 2, how do we get that to be 5? Well, we could multiply by 1.5 or 2.5, sorry. So if I write in 2.5 here, okay, if I go through and add up my oxygens, I have 1 here, 2 here, so that's 3. And then 2.5 times 2 is 5, so 5 plus 3 would give me 8. Okay, so now I have 8. So you'll see that they're all matching, okay? But the problem is we can't have a half of an oxygen molecule, okay? We can't have any decimals used as our coefficient up in our problem. So what we have to do is we have to get rid of the decimal by multiplying each of the molecules or compounds by the same number. So in this case, we'll use 2 in order to get rid of the decimal. Okay, let me make some room real quick. Erase this. I'll change my color as well. So if I multiply each of them by 2, this one, 2 times 2 would give me 4. Okay, here there's an imaginary 1. Okay, it's understood 1, so 2 times 1 will give me 2. For this, 2 times 2 will give me 4, and then 2 times 2.5 will give me 5. Okay, so those should be the coefficients I need to use to balance the equation. So before we were like, oh yeah, it's totally balanced, we need to actually make sure and count each side, okay? So for potassium on the reactant side, 4 times my subscript of 1 will give me 4, okay? 4 times my 1 magnesium will give me 4, and then 4 times my 4 oxygen will give me 16, okay? On the product side, 2 times my 2 potassium will give me 4. Okay, so that is now balanced. Okay, they're matched. For magnesium, I have 4 times my 1 magnesium, which will give me 4. So those are now matching. Okay, and then lastly, my oxygen, I have 2 times my 1 oxygen, so 2 oxygen here. 4 times my 1 is 4, so I have a total of 6 now. 2 plus 4 is 6. And then 5 times 2 will give me 10, so 10 plus 6 will give me 16, which is also matching. Okay, so if you get stuck to that one place, you can use a decimal to at least get you unstuck, and then you'll have to multiply all of the different molecules or compounds by either 2 or 3 in order to get rid of the decimal. Usually it'll probably be 2 for you guys in order to get rid of that decimal and balance the equation.